The main purpose of this example is to further demonstrate the critical importance of the design total optical thickness to achieve a good match to the target spectral characteristics. In the File - Project menu of OptiLayer, open the directory LEC25D6. Make sure that optical thicknesses are chosen in the Settings part of the configuration menu. Load into RAM the data files needed to run this exercise. These are the substrate glass N equals 1.52 and the layer materials N equals 2.35 and N equals 1.46. There are 2 items in the target database. These are AR 400 to 1000 nanometers and band pass filter. Use the preview option to view both targets. Load the AR target into RAM. In the design database, there is a single layer starting design H layer TOT 400 nanometers with an optical thickness of 400 nanometers. Load this design into RAM and open the TAN-RAN phase evaluation window to see the correspondence between the transmittance of the starting design and the target transmittance. In the Synthesis menu, select the Needle Optimization Auto Mode and click the Run button in the lower left corner of its window. In a fraction of a second, the final design is obtained. The achieved merit function value, MF, number of design layers, N, and total thickness of the design, TT, are shown in the top line of the window representing the history of the Needle optimization procedure. Make sure that in the configuration - settings optical thicknesses are selected as thickness units for the design representation. To save the obtained design, click the Load button in the lower right part of the window. The obtained design is now presented in the TAN-RAN phase evaluation window and you can save it in the design database using Data-Save Data-Save Design option. Note that there is already the design 8-layer AR in the design database that was previously obtained using the same starting design. It has excellent anti-reflection properties in a wide spectral region of 400 to 1000 nanometers. In the design database, select the starting design H-layer TOT 800 nanometers with an optical thickness of 800 nanometers and load it into RAM. Run the Needle Optimization Auto Mode. The design with even better anti-reflection properties is obtained. See the achieved merit function value, number of design layers, and total thickness of the design in the top line of the window representing the history of the Needle optimization procedure. It is saved in the design database as a 16-layer AR design. It is worth seeing the reflectances of both designs on a scale of a few %. Let us now look at designing a band pass filter with the target transmittance band pass filter. Load this target file into RAM. Try running the Needle optimization auto procedure with both of the starting designs used previously. The procedure does not allow one to find a solution to the design problem under consideration. The explanation to the failure of the Needle optimization procedure in both cases is that we do not have a starting design with sufficient total optical thickness. There is a fundamental difference between the previously considered AR target and the new band pass filter target. The latter have requirements for transitions between high transmittance and high reflection in narrow spectral regions around 500 nanometers and 600 nanometers. It has been shown theoretically that such requirements can only be fulfilled if the design total optical thickness is sufficiently large. In the design database, there is a single layer starting design H-layer TOT 4000 nanometers, which has 10 times the optical thickness of the design H-layer TOT 400 nanometers. Running the Needle optimization procedure with such a thick starting design and quasi-Newton method immediately gives a fairly good band pass filter design. It is saved in the design database as a 35-layer BPF by quasi-Newton. Using an even thicker starting design H-layer TOT 6000 nanometers gives a filter design whose MF value is 4 times lower than before. Examples of such designs are saved in the design database. Conclusion: once again, we see that the design total optical thickness is an extremely important design parameter.